Okay, so next up is simulating the tablecloth from the concept. And we can see there's some really nice folds and wrinkles in here. And we've got a pretty good impression of what it needs to look like. We've also got a reference image for the cloth as well, so we're going to be following that. And what I'd like to do is just simulate this cloth and make it a little bit longer and make it drape over the chairs. I think that helps with sort of grounding the chairs as well and making the cloth feel like it's sort of integrated with the scene. So with that said, let's dive straight into it. I've not taught vellum before, and this has been a really cool asset to work on, so I'm excited to show you guys this. Okay, let's dive straight into this. I'll drop down a geometry node. We'll call it tablecloth. Jump inside. We'll import our colliders for the cloth. So I'll drop down a file sop to import that. Jump into the BGO cache folder and import our table for cloth collision. So you can see this is not at 0. So this has been exported from the main scene. So it's already, the table's already in position, and I thought that'd just be a bit easier to simulate the cloth on, and then I can just export it without having to move it. Let's Alt left click on this file sop. So we're duplicating it, and we'll also import the cushions for the collision. We'll merge these two pieces of geometry together like that. So we have two colliders now, and we'll drop down a convert sop to convert this to geometry, or as readable geometry. I found that if I didn't have this convert sop down, the basically vellum doesn't consider this geometry, so that's the reason for the convert sop. What we're going to do now is create the cloth, and we'll use a plane for this, so a planar patch. We'll add a merge, and we'll merge this planar patch with our collider geometry so we can visualize what's happening. So we've got our rectangular patch there. We'll change this to a circle, and we'll change the build plane to ZX so it's facing up. I'll hit enter on the keyboard to bring up the move handle, hit T to access the move handle. I'm just going to move this into place. Space 2 on the keyboard to go to the top view, W on the keyboard to go into wireframe mode. We're going to line this up the best we can. I'm going to chuck it sort of right in the middle of that table, but it doesn't have to be dead center. So somewhere around there is absolutely fine. We'll copy the X channel, paste it to the Y, and I'll increase this to around 2.25. So the tablecloth is bigger than the table. I'll hit W again to come out of wireframe, so we're in shaded, and I'm going to lift this cloth up just above the table. And the reason I'm not going to lift the cloth up that far is because this would increase the simulation time. So we want this cloth to hit the table as fast as possible. So I'm going to hit space 3 to go to the front view. We're going to drag that right down so this cloth collides straight away with the table. There you go. Space 1 back to perspective view. And we can now snip this here. The first vellum sop we need is a vellum constraint sop. So vellum constraints. The first input is asking for vellum geometry. So this is our planar patch. The second input is asking for constraint geometry. We're not going to use that. And the third input is our collision geometry. So our table and cushions. And we're going to change the constraint type to cloth, which is nice and simple. The next sop we need to place down is a vellum drape sop to drape that cloth over the surface. We're going to plug in all three inputs. It's nice and straightforward. So now you can see whatever's in blue is our collider, and we have our cloth in grey. We can increase the resolution of the planar patch by decreasing the edge length value. So I could put in something like 0.05 and start with that for now, maybe even a little bit more. And most of our parameters we will change on the vellum constraint. So right in here. Let's hit simulate to see what kind of result we get. So as you can see, it's not looking too great. We need more resolution in the cloth. It looks very stiff as well. Before we move on to refining the look of this, I'll import our reference image so we can compare the difference. So we can see this is sort of drastically off. Let's go back to the start. Increase the resolution again to maybe like 0.025. Fire that back off, viewing from the bottom stop in the chain. See how that's looking. So it's still not looking too great. We can see the cloth is sort of catching on the edge of the cushion. It's still very stiff. And if you take a look at the reference, we can see lots of these folds. I think there's like, so if we count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like, so around 11 or 12 per half of the table. So we definitely don't have that many folds at the moment. So the way we can do this is by messing around mainly with the stretch stiffness and the bend stiffness. And these two settings will sort of give us our desired look. So right now, the higher this number is, the stiffer the cloth is going to be. So let's just take this down to something like 10 so I can demonstrate the effect this has. Let's hit play. And I'm just going to decrease the resolution just to speed things up a little bit. So you can see it looks more like lava or something. It's like stretching way too much. So that is not looking great. So you don't want to put that number too low. And by default, this has 10 zeros after it. So we can try adding maybe like 4 or 5, play around with it, see what it looks like. And I found that I sort of had to tweak these numbers a little bit and just have a mess around with different values. But a value that worked for me was 1 with 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was a nice stiffness for me. That seemed to work well. So the stiffness seems sort of about right, but we're going to need to add more bending. So we can reduce the stiffness on here. And I went with the setting, so I halved this basically. So I went with the setting of 0.05. So we're making the bend stiffness less. So it's a little bit more bendy. Still a little bit difficult to see because we don't have a lot of resolution in the cloth. So let's take a look at changing that. We'll take this down to 0.01. Wait for that to compute a moment. There you go, so we've really increased the res there. So those two settings are very important to the bend stiffness and the stretch stiffness. You'll probably get most of your results just from those two settings. Just going to drink my coffee whilst this simulates. So we're getting some nice detail in there, some nice sort of folds and striations. And to get the sort of desired look, I usually let the simulation run for a good 250 frames and wait for that cloth to settle. You don't want to save out an OBJ of this cloth when it's sort of swaying inwards or outwards. You want the cloth to be nice and settled and still, and then export it. So I think that's taken some really nice shape. Let's just stop it and we'll just take a look around, see what this looks like. I think that's looking kind of cool. I still think it's lacking in resolution. I think the resolution really adds something to it. So it's getting there. It's getting pretty close. We've got those nice folds. There's quite a few of them as well, which kind of matches. Remember here, this cloth is not colliding with anything. And also one thing to note is that these folds are starting sort of all the way from the top and down. If you've got too much bend stiffness, you probably won't get a fold at the top. It will just start to stretch at the end and bend at the end. So that's a bit of a giveaway. So that will make it sort of not look like cloth. And I'd say that when we're shading and look deving this asset, it is very, very dependent on how the cloth is simulated. The cloth should feel real. It should look real. Just with a basic shader on it. So it really is about simulating nice folds and making sure that you've simulated it correctly and realistically. So always have your reference with you when you're doing it. I'm just going to check over my settings. I don't think there is anything else that I changed in here. I'll leave some notes in the scene as well for you guys, just a sticky note, so you can copy your own settings in. I'll also provide the scene as well. Yeah, I think that's absolutely fine. So to set this render off, what we want to do is increase the final resolution to a lower number to really subdivide that mesh. And let's just quickly have a chat about UVing this asset. So we'll drop this back down to, like, I don't know, 0.1. So this is nice and fast. We'll drop a UV quick shade down. And this is actually very important you do this step before you simulate. So we'll drop a UV quick shade down, view. So this is similar to adding like a checkerboard in Maya. So we're actually viewing the UVs of this planar patch. And everything seems to be looking in good order. But if I simulate this now, and let's say we add the UV quick shade right afterwards, still looks okay, still looks fine. But when we simulate, you'll notice the UVs get all distorted. and we definitely don't want that. So what I do to counteract this and fix it is drop down a UV texture SOP, which is the same as a planar mapping in Maya, and we can plug this in so we can see what it looks like. Looks like the UVs are sort of flipped horizontally, so we can flip them in X, so -1. We'll do that on the UV texture SOP, sorry. So -1 on here. There you go, so the UVs are the right way around now, and there's nothing else we need to do. That's pretty much it. So let's plug that back in, and so basically Vellum is taking in a UV'd planar patch. So before we didn't have this, now we do. Let's see what result we get. So you can see distortion there. We'll go back, we'll replay it, and we can see now the UVs are retained, or they're retaining their shape, and it's looking cool. Okay, so the final setting for me was 0.007, and I waited probably about 30 minutes for this to simulate, and it took around, I think around 20, it took around 30 minutes. And I simulated around 250 to 300 frames just to wait for that to settle. So once that's done, I'll come back to you guys, and then we'll finish off the process. And there's one more node in the Vellum process that we need to use to sort of add some thickness to it, and then we'll export the geometry for look deving. Okay, so I'm back after simulating this cloth. It took around 30 minutes to do so at an edge length of 0.007. I didn't change any other settings. So what we want to do now that it's simulated, I've stopped this at 269 frames to let that cloth settle so it's not swaying back and forth. We're going to add a Vellum process, or Vellum post process, and this is the required Vellum geometry, so we'll just plug that in. I think we'll plug all of it in actually, and we're going to view from this post process. What I like to do just to smooth out any sort of lumps is to add a little bit of spatial blurring, so around 0.3. That's just going to smooth that mesh out just a little bit. I'm not sure if you guys can see this on the screen, but it just smooths it out by just a touch. Maybe we could go up to 0.5, but remember, as we're doing this, we're losing probably a little bit of detail, but yeah, not too much there, which is cool. I think I'll probably go with 0.3, which is my usual result. And then what we want to do is add some thickness to the cloth. So I've written down cloth thicknesses here, and this is the one I went with, so a medium heavyweight, so 0.010 of an inch, and I just converted that to meters. And I'm not actually sure in Houdini works in meters generally speaking, but I'm not sure when we turn this extrude by thickness on what this is based on, what unit this is based on. So it could be centimeters, I'm not too sure, so we're going to check that out now. So I converted these inches to meters, so we're just going to copy that. Extrude by thickness. So way too thick. Let's try inputting that number and we'll see what kind of result we get. So you can see that's like way too thin. Let's turn it off. Turn it on, yeah, too thin. So we'll take a 0 out. I still think that's too thin. Take another 0 out. It's kind of getting there. Maybe 2.254. And it looks like we pushed that a little bit too far there. Let's let that 0 back in. I'm not entirely sure if that's thick enough there, so maybe we'll go up to something like 3.5. It's looking a little bit on the sharp side. So let's go up to maybe 0.1. Just sort of rotating, looking around. It's difficult to tell from here really. And you can have a play around with the setting and just see what different results give you. But I think that's probably not too far off. It's maybe just a touch too thick, possibly. Just looking at the edge here. Yeah, I think that's maybe a touch too thick. So let's drop that down by a little bit. Yeah, I think that's more appropriate. Yeah, I'm happy with that. Let's go with that. So once you've done this, we've added some spatial blurring to smooth out the mesh. The mesh is currently triangulated, so I don't want that. I'll use Catmull clock to subdivide it. So this will create quads. We'll wait for that to compute. There you go. So we now have quads. So if you wanted to subdivide this at render time or add a displacement map, you could. I'm going to merge in our chair. So basically our collider geometry. Let's merge that in to see how this is sitting here. And we can see there's some kind of collision issue, which I think is handled in the post-process here. I think maybe you can use this collision correction, possibly. But I think what I'll do instead is I'll just add a transform swap in here. And I'll just move this cloth down in Y until that kind of hits the chair. And there may be a better way of doing this, but this is the way that I did it anyway. So I think we'll do finer increments there. Lift him up. Just until that's, there you go. I think that's about right there. Yeah, I think that's looking cool. So let's view from the transform now. That's looking nice. I'll drop down a ROP geometry output to save this out as an OBJ. So go to job, cache, OBJ, and we'll save it out as vellum tablecloth. So you can see I've done quite a few iterations here. Save that as V008. Make sure it's got the .obj extension. Save to disk. That doesn't take too long to save that frame out. Okay, so that's all saved out, and I think we can go ahead and start look deving the cloth. So that was really good fun simulating the cloth. Let's finish this off and add the final touches in look dev. So once you've loaded in the OBJ, we'll drop down a material network. We'll call this tablecloth underscore mat. We'll drop down an RS material, call that the same. We'll also pipe this into a redshift material, which is the same as a shading group in Maya that goes right at the end of the chain. We'll apply that material. Let's pull up the render view, redshift, open the render view. I've just moved my camera, my look dev camera, sort of around it. So I'll just zoom in, frame it up a little bit better. Hit play. We'll select the look dev camera. Stop that. Replay it. So we have ourselves a very shiny looking cloth material. Not too convincing. We'll change the BRDF to GGX for slightly more realistic shading. I usually increase, for cotton, I usually increase the roughness value to probably somewhere around 0.8. I think somewhere around there. You can have a slide around with it. I think 0.8 works well. Let's import our albedo map. And the albedo map we're going to be using is from friendlyshade.com, and they have a fabric collection. It's really, really good, and it's super high resolution, so I definitely recommend these guys. They're really, really good website. So let's load that in. So the digital assets library, textures, fabric, jump inside, and I think it's, yeah, plain fabric 09. Load in that albedo, set from the file name, and we'll plug this into the diffuse. Restart the render. So not looking too great, so it looks like we need to tile it. So I copy the X channel, paste it into the Y, and I tile this by something like, you can keep going up and you can see how it looks and compare it to their result. So I think something like 8 worked quite well for me. So you can't see it that much, but if you zoom in, then it becomes more obvious. So what we want to do is we want to get the nice edge highlighting. So we need to use an RS Fresnel for this. So an RS Fresnel node. We'll plug this into the tablecloth out so we can view the flat color of this RS Fresnel node. We'll turn the use index refraction off, and what we can do is we can just slide this down till we get like a nice softer result. I think something around 2 sort of works well. I'm just comparing the way these highlights are falling off. I think that's kind of working. I think that looks kind of cool, so a value of 2 is fine. And the reason I turn off this use index of refraction is so I can plug my albedo map into the facing color and the perpendicular color. So the facing color is whatever is facing the camera, so you can see that's black. So that's the facing color, and the perpendicular color is facing away from the camera, so the edges. So let's plug in our texture map into the facing color slot, which gives us that. There's no map in the perpendicular color slot, so it's just white. So as you can see here, so if I turn this down, then you can see the effect it's having, or I turn it up, and we get this result. What we want to do is we want to take albedo map, and we want to brighten the albedo map up. So we'll take an RS color correct, plug it into the perpendicular color. So we're just viewing basically the albedo texture now. So what we need to do is just lift up the gamma a little bit, something around that, just to soften it out a little bit, and then you can scale up the level. So the perpendicular color is using the albedo map, but it's brighter, which is why we're able to see it. So I think something around those kind of values is fine. Maybe a little bit too strong. Yeah, I think that's going to work. I think something around there will work. I think that looks cool. Let's plug in our RS material, see what that looks like. Refresh the render. We'll do bucket rendering. Take a snapshot, so that's without the RS Fresnel node. plug this in, and we get that happening. So it looks like we've gone, I think, a little bit too much here, so maybe like 1.5 is fine. So we want every effect really to be subtle, I guess. Oops, move the camera. So I think that's looking quite cool. It's kind of difficult to see though because we've got a lot of noise. So I'm going to go in, I'm going to turn this up to, I think, about 128 samples, just to clear that noise. Jump back into the material network. That's looking quite cool. Let's add a normal map to this. Copy the path location from here. Paste him in. That didn't work, did it? Copy it one more time and paste him in. Let's browse for the normal map. We'll plug the normal map into the bump input here. We'll copy the scale, so how many times this texture is repeated. Go to the advanced tab and paste it in there. So we'll just do a quick refresh. I think we'll zoom in as well for this so we can see it a little bit better. So we can start to see that material's popping a little bit better. Just switching back and forth there. So that's looking kind of cool. I think what we can do as well is start to add some creases into this texture as well. So let's create another RS normal map, and we're going to mix in, or we're going to mix two normal maps together. So I think this will be the cotton fabric 02. Let's mix this in using our RS bump blender, like so. So the base is our cotton normal, and the normal map on top is the creases. So if we plug that in now, we shouldn't see any difference. We should just be getting the normal map from the cotton. Yep. So what we need to do is give this a mask. So what we can do is drop down an RS color constant. We can just give it a fully white mask, like that. That's looking pretty cool. We can turn on additive mode. So now we're getting both normal maps together. But we kind of don't want the creases all over the surface. We just want them sort of in areas, in different areas. So we need to, we could use a procedural method for this. So we could use an RS noise, but I think I'll use just like a grunge texture or something, just to give a bit of breakup. So we'll load in our grunge texture. It's grunge. Grab that grunge texture. I just want to see what this looks like here. Okay. Let's plug this into the bump weight instead. So now wherever there's white, we'll get creases. Wherever there's black, we'll see the plain fabric normal. Okay, let's view this, let's see what it looks like. Just refresh the render. Let's drop an RS change range to sort of remap those black and white values, because it's not very strong at all. So the first thing we can do to get layer 1 to show up is by boosting those white levels from this mask. So let's boost that up to 5 or something crazy. So we got this happening. I think let's try 2. I don't want to boost it up too much. Okay, that's kind of looking cool. I think that has quite a nice effect actually. Looks kind of cool. Let's say, for example, we turn this up to something like 10, all right? This is going to stand out so much. And let's say we don't want as much creases. What we can do is just add contrast to this map. So we basically want to introduce a little bit more black. So if we introduce more black, then we'll create contrast in this map, and this map is driving the mask. So this is determining where these creases are getting revealed. So like I said, wherever there's white in this mask, the creases will get revealed. If we introduce contrast and lift up those black levels, or introduce more black into the image, which we just did, then we're going to be seeing less creases. So I can just increase that up a little bit more. You'll see less of them. I put this down to 0 and you'll see all of them. So I think something like 0.15 maybe. I think that kind of works. That kind of looks cool. Let's mess around with the tiling as well. Let's see what that does. Let's try go up to 1.5. So we're tiling the creases now. So this is nothing to do with the mask or where they're appearing. Okay, that looks alright. Let's turn him down. So we'll turn him down to like 2. Looks kind of cool. I'm going to push those white values up a little bit more so they stand out. We can drop this down to 0.1. So we're getting more creases over the surface. And I think overall that's looking kind of cool. We could tile this even more. Maybe like 2.5. See what that looks like. Yeah, I think that gives quite a nice look. Let's take a snapshot. Let's turn the mask off so we're going to get no creases. And we'll just compare. So there you go. We're adding a little bit more detail in there. I think this could actually be turned down. So we'll turn the normal map down to maybe like 1.25. I don't want it to be quite that strong. And yeah, maybe something like that. I think that works pretty nicely. Just going to hit save. Let's go a little bit closer up. And actually before that, we'll have a little mess around with the backlighting. So let's lift up the backlighting weight. We'll lift that up to something like 1 just to test this out, and you'll notice it will go darker. And usually this happens for one of a few reasons. One of them, it could be that we don't have enough in the environment to see the backlighting happening. 2, it could be that we're at the wrong angle because the sunlight's coming in from the left here. So technically we should be behind the sun. And 3, I find turning on brute force as the secondary GI engine tends to make a pretty big difference. So we can take a snapshot there and turn on brute force in here. So you can see now we're getting that backlighting through. It's pretty damn strong. So we'll jump back in, leave brute force on as the primary and secondary engine. So we're getting basically more bounce light. We want to sort of control how much backlighting we're getting, and we also want to base this on the texture. So let's plug the texture into the translucency weight. We'll leave the color, the backlighting color, as 1. Just going to hit re-render. And that gives us that. Let's add an RS change range here, so we can change those white levels. We can turn them up and down. So right now the white levels are probably between 0 and 1, maybe more towards 1. So that is what's driving this weight. So I'm not sure where the weight is right now. So what we can do is we can turn this to, we'll take a snapshot. So that's at 1. We can turn this down to 0. Wait for that to render a moment. I think we'll restart the render. Didn't seem to like that one. Okay, so this is without, this is with, so I think there's way too much. Let's push this up to about 0.5, I think. So the maximum backlighting we're getting is 0.5 now, which is determined by this new range max. So we've halved the amount of backlight. So I think that's looking really cool. Another thing we can do to push this is that I'd like to add a little bit of transparency, just so that you can see through the cloth a little bit. And there's two ways we can do this. One is by using refraction, so we can pull up the refraction weight. And this method I wouldn't recommend because we're going to add to the render times. So I wouldn't use refraction for this. What I would use is opacity, which is the same thing as, you know, opacity mapping leaves, you know, where you use cutouts for leaves. So like on a leaf, wherever there's white, the leaf would be. Wherever there's black, there wouldn't be any part of that texture showing. So in the same sense, we could drop this opacity down to like, let's try 0. So technically this should disappear now. We shouldn't be able to see the cloth. And the reason we're seeing the cloth is because on our ROPNet, we've disabled refractions. So as much as this is not a refractive method, opacity shows up in the refraction AOV. So we basically need to turn this on. So if it's not on, it's not going to work. So once we turn that on, let's dive back in and let's turn the opacity up to something like 0.5. Let's see what that looks like. So it's looking a little bit ghostly. Let's turn this up, I think, to around 0.9, which is a setting that I sort of arrived at in my final scene. I think it's looking pretty cool. I think it looks quite nice. Yeah, I think that's looking pretty cool. Just gonna hit save. Just taking a look around just to see if there's anything else we can do to improve this shader. But I think overall that's looking pretty cool. Let's take a snapshot. We'll zoom in as well. Let's zoom into around here. Nice and close. Refresh the render and see how we're looking. I'm also comparing to this. And I usually wouldn't recommend using CG as reference, but this is actually a really good reference. It looks pretty damn good. So I don't think we're far off here. I think this is matching quite nicely. I'd also recommend checking out reference images of real life. So let's go to job, reference, and pull in our tablecloth reference, which is here. So you can see it's not as strong with this sort of bump detail here, but it does look like it's got those creases in there, which kind of looks more soft, like the creases we have here. So I really don't think that's too far off. Plus as well, when we've got our sunlight in here, we're going to get more blowout. It's going to get, overall the shadows are going to get a bit more lifted. So you might need to sort of update this based on whatever scene you're in. But you shouldn't have to make too many updates. So just maybe a few parameters might need tweaking. But I think overall that's a really good shader for cloth and making the cloth look nice and real. Let's take a look at this angle. yeah, I think that's looking kind of nice. I think maybe this could be tiled a little bit more so the details are smaller, but seeing as though we're pretty far away, I think that's going to be absolutely fine. So I'm pretty happy with those results. That's looking pretty cool.